Hello students. Now we are going to start 6th chapter Circle Mathematics 2 Practice set 6.2 of Standard 9. This is the part 3 of Circle. So I'm Mrs. Lalita Ramne and let's start the practice set 6.2. So properties of congruent chords. There are two properties of congruent chords. The first power property, that is nothing but the theorem 1. Congruent chords of a circle are equidistant from the center of the circle. If the chords are congruent to each other, then they are definitely equidistant from the center of the circle. What says the theorem number 2? The chords of a circle equidistant from the center of a circle are congruent. If the distance from the center is equidistant to the chord, then the chords are also congruent to each other. So these are the two properties of congruent chords. Now let's see the questions based on the properties. The first question says the radius of a circle is 10 centimeter. There are two chords of length 16 centimeter each. What will be the distance of this chords from the center of the circle? So what is given to us? Radius is given to us. Two chords are given to us. Their length is 16 centimeter. And we have to find out the distance of this chord from the center of the circle. यानी center से chord तक का distance हमको निकालना है. So this is the AB is the chord, right? CD is the another chord of 16 centimeter each that is given to us. The length of the chord is given to us. The radius of a circle is given to us 10 centimeter. We are considering that OM is perpendicular to the chord AB. Therefore, M is the midpoint for the chord AB. Similarly, ON is perpendicular to the chord CD and therefore N is the midpoint for the chord CD. Now let's see how we can find out the OM. Right, in the previous exercise we discussed about that perpendicular drawn from the center of the circle to its chord bisects the chord. Means AB is given to us 16 centimeter. Therefore, M is the midpoint. So AM is equal to half of 16. Right. So AM and MB becomes 8 centimeter. Now let's see the solution. First we will write the given according to the question. Let us consider the center of the circle BO. Segment AB and segment CD are the two chords. OM is perpendicular to the chord AB and ON is perpendicular to the chord or segment CD. OA and OC 10 centimeter, that is nothing but the radius of the circle that is given to us. And AB and CD, the chords are given to us are of 16 centimeter each. What we have to find? We have to find segment OM and segment ON. Now let's see the solution. First we have to find out the distance of AM, means the chord AM. Right, AB is the whole chord that is given to us 16 centimeter, but we don't know the length of AM. So first we have to find out the AM. And how we can find out the AM? AM is equal to half of AB by the theorem perpendicular drawn from the center of the circle to its chord bisects the chord. And substitute the value. AM is equal to half of AB. AB is given to us 16 centimeter. Therefore, 2 8 is 16. Therefore, AM is equal to 8 centimeter. Now we know that triangle OMP is the right angle triangle. So in the right angle triangle, we can use the Pythagoras theorem. We know the formula for the Pythagoras theorem. Hypotenuse square is equal to perpendicular square plus base square. Now according to the distance, substitute the values. Hypotenuse is our OM square plus AM square plus is equal to OA square. Right? So after substituting the value, we are getting OM square whole square plus AM is equal to 8 and OA is the hypotenuse, that is 10. So after transposing, we are getting OM whole square is equal to 10 square minus 8 whole square. So 10 minus 8 and 10 plus 8. Here I use the A minus B and A plus B identity formula. You can go for the directly 10 square also. But this is the simplest way. So 10 minus 8, that is 2, and 10 plus 8, that is 18. So now 18 to the 36. So we want to remove that square from the OM. So we have to take the square root on both sides. So by taking the square root on both sides, we are getting OM is equal to 6 centimeter because under root of 36 is a perfect square root of 6. Now OM and ON also become 6 centimeter because the chords are equidistant. Congruent chords are equidistant from the center of the circle. Therefore, the distance of these two chords from the center of the circle is of 6 centimeter. Easy. Now see the question number 2. In a circle with radius 13 centimeter, two equal chords are at a distance of 5 centimeter from the center. Find the length of the chords. Means what is given to us. AB is the chord. Again the same units and same type of vertex I used over here, points, right? So what is given to us, AB and CD are the two chords where OA is given to you, that is nothing but a radius is of 13 centimeter. OC is of 13 centimeter, OM is of 5 centimeter, and ON is also of 5 centimeter. That is nothing but the distance from the center to the chord. Now what we have to find? We have to find out the length of the chord, that is AB and CD. Okay, now you can observe the triangle is again the right angle triangle, right? So in the right angle triangle, we can apply the Pythagoras theorem. So let's see, the given is the same. Let the center of the circle be O. Segment AB and segment CD are the two chords. OM is perpendicular to the segment AB and segment ON is perpendicular to the segment CD. OA and OC are of 13 centimeter, that is nothing but the radius. OM and ON is of 5 centimeter. To find, what we have to find? Chord AB and chord CD. Solution. Triangle is a right angle triangle, so apply the Pythagoras theorem here. Again the same formula. Hypotenuse square is equal to perpendicular square plus base square. Now after substituting the variables, OM whole square plus OM whole square is equal to OA square. Now we are getting, after substituting the value, AM whole square plus 5 square is equal to 13 whole square. Now transpose this 5 square to the right hand side. So AM whole square is equal to 13 square minus 5 square. So AM whole square is equal to again A minus B, A plus B. So 13 minus 5, 13 plus 5. So 13 minus 5, that is 8, and 13 plus 5, that is 18. So 18 into 8, that is 144. Now taking square root on both sides. So AM whole square, under root of AM whole square is equal to under root of 144. Now therefore AM is equal to 12 centimeter. Here we are getting AM is equal to 12 centimeter. But we know that perpendicular drawn from the center of the circle to its chord bisects the chord. Right, so AM is equal to half of AB. Now we know the AM is of 12 centimeter. Now substitute the value. So 12 is equal to half of AB. Now this half. Now again this 2 in the division. When you transpose it to the left hand side. So 12 into 2 is equal to AB. So AB is equal to 24 centimeter. But chord AB and chord CD, that is given to us that they are congruent to each other. So if AB is of 24 centimeter, so CD is also becomes 24 centimeter. Therefore, the length of the two chords of the circle is of 24 centimeter each. Now see the question number 3rd, last question of the practice set 6.2. Segment PM and segment PN are congruent chords of a circle with the center C, so that the ray PC is the bisector of angle NPM. A very interesting question, see children. PM and PN, they both are congruent to each other, that is given to us. And C is the center of the circle. If you observe the CM and CN, they both are nothing but the radius of the same circle. Right? What we have to prove, that PC is the bisector of angle NPM. PC is the bisector, means what we have to do, we have to show that the angle MPC and NPC, they both becomes congruent to each other, because we have to prove that PC is the bisector. And once we have to prove that bisector, मतलब ये angle को जो है, ये MPN जो angle है, ये क्या है, equally divide हो रहे हैं. So how we can prove it? See, given segment PM congruent to segment PN of circle with center C. What we have to show? PC is the bisector of angle NPM. Now proof. Again you are observing the two triangles are given to you, MPC and triangle NPC. Right? What is given to us? PM and PN, they both are congruent to each other, that is already given to us. Second, PC is the common side for both the triangles. Third, MC and NC, they are nothing but the radius of the same circle. Therefore, by side test, we are proving that triangle MPC and NPC, they both becomes congruent to each other. And once we prove the triangles are congruent to each other, so we can find out the remaining parts also of the triangle. So here we use all the sides. So remaining angles are only there, right? So here we can say the CPM and angle CPN, they both becomes congruent to each other by CSAT, means corresponding angles of congruent triangles. So here we are proving the ray PC is the bisector of angle NPM. Okay, so practice for the practice set 6.2. Soon we will meet with the next video. Thank you very much.